Okay, hopefully everyone can hear me. I'm going to go ahead and get started here. I know we might have a few more participants jumping on here in the next few minutes, but we'll just go ahead and dive into our introduction. Thank you so much to everyone for being here with us today. I know it can be really hard to make time in your schedules, and we have people from all over the world, so time zones can be difficult. But we appreciate you taking the time to be here with us virtually, as is the only way we can all be together during COVID. So I just want to remind you guys that we are open right now. Most of our staff is working remotely, but our production facilities are working at full capacity. And if anything changes with that, we will let you know. We hope that everyone is staying safe and staying well. Today, we would like to present an introduction to our MBBR products and services. We will be diving, we will be diving into some technical information about our media and our products, as well as some general sales tools to help you speak with your clients. In a few weeks, we will be conducting another webinar that dives much more deeply into the technical design considerations and benefits of MBBR, as well as some specific case studies. So if you're really looking to dive deeper into that technical content, I encourage you to please join us in a few weeks. We will be sending out an email blast about when that will be happening. So a little introduction to who we are. 4 years ago, SSI expanded to include an on-staff process engineering team. This includes Bob Freudenberg, Jason Bowman, and myself, Kelsey Bennett. We tried to do a theme here with all of our dogs. Unfortunately, Bob couldn't find a picture with his dog, but he also has a very cute dog at home. Bob Freudenberg has over 30 years in the industry designing and executing wastewater treatment systems. Jason Bowman has over 15 years in the industry designing both biological and physical process systems. And I have experience here in the US in engineering consulting for wastewater and drinking water treatment. Altogether, we have pretty extensive experience in not just biological systems and not just fixed film systems, but full wastewater process. So many of you may already be familiar with SSI. In fact, you may have been working with us for decades. In that time, you will have noticed that we are always striving to innovate so that we may better serve our customers. This may be in the form of improving price points, creating more sustainable products, but mainly we are always striving to improve the life expectancy, the performance, and the ease of operations for our customers. This is how we ended up branching into the MBBR business 4 years ago. So let's dive into a little bit of MBBR background. I know not everyone is familiar with MBBR, especially those in the municipal markets where conventional activated sludge is much more common. So in an MBBR system, instead of having the bacteria suspended in the water, it is actually attached to biofilm carriers, which are kind of like little pieces of plastic floating throughout the tank. Now, the historical benefits of this was that it allows for a smaller footprint and it's easy to retrofit. What that really means is that what we've seen is that MBBRs were installed for 2 reasons. One was due to space constraints. Maybe you are in a city or you are already on an existing facility where you only have a small footprint. MBBR is a good fit. Another example is if you already have an existing plant and you want to retrofit without additional construction. MBBR can be added to your existing tanks to expand your flow capacity without any more civil construction. Another thing I'd like to note is that historically, MBBR has been paired with coarse bubble aeration. This is because it's somewhat of a challenge to access the aeration grids on the bottom of the tank, because when you drain your tank, you have to move the media out of the way to be able to maintenance your aeration system. So operators were not too keen on having to maintain their aeration system, the fine bubble diffusers on the bottom of the tank more frequently because of this challenge. However, in 2004, SSI came out with our PTFE membranes, which completely innovated the MBBR process. PTFE membranes have a longer lifespan. They have less fouling, which means less cleaning. They also have a consistent oxygen transfer efficiency over time, which means less energy consumption over the lifespan. When you pair the PTFE membranes with MBBR, now you can have a more efficient system that utilizes fine bubble aeration without the operational challenges of the past. So diving a little bit more into the MBBR process and the benefits that we receive from that. As I said before, the biology is attached, not suspended in the water. What this means is that you don't have any return activated sludge. You don't have to monitor your MLSS, food to mass ratio, or your sludge age. Altogether, this creates simpler operations. This can be really important for clients who may be in more rural areas where they don't have access to highly trained operators. No consistent monitoring, no daily adjustments. Instead, they have a system that's more self-sustaining and hands-off. Another thing is that you're able to stage the biology. In a conventional activated sludge system, the bacteria is suspended in the water, which means it flows with the water through all stages of the plant. However, in an MBBR system, because the bacteria is attached, it stays within a specific tank. So now you can have 2 or 3 MBBR reactors in series and growing completely different biofilm in each tank. The first tank, you might have biofilm that adapts to consume more readily biodegradable substances. So this is things that are going to break down very quickly. You might see a quick reduction in BOD or COD. By the time the water moves to the second tank, now that stuff is gone and you're left with the harder to consume, the harder to break down constituents. But the biology that is in that tank stays in that tank. So it's able to adapt to consume those higher chain hydrocarbons and break down those more challenging substances. Overall, what you get is more efficient treatment of challenging wastewaters. Now, you also get resiliency to flow and load fluctuations because the biology is attached, as I said. If, let's say, there's a big storm and your wastewater plant is also attached to the stormwater network, now you have a huge fluctuation in flow. Historically, if you have a suspended system, you might wash out your biology during this storm. But because of the MBBR system, you're not going to wash out your biology. You're going to be able to restart your plant much more quicker. You're going to be able to achieve the treatment levels you were getting before much quicker. You don't have to regrow all of the biofilm. When you pair the MBBR process with fine bubble aeration, you get even more benefits. So the fine bubble aeration has smaller bubbles than coarse bubble, and so you have a higher oxygen transfer efficiency. What this means is you use less air to achieve the same dissolved oxygen within your tank. Less air means less energy consumption. And we all know that the energy for an aeration system in a wastewater plant is the top operational cost of the plant. So if you're saving energy in your aeration, you have significant operational cost savings. That's a really big benefit to your end user. In addition to that, with fine bubble aeration, you'll get better mixing throughout the tank. We use full floor coverage with fine bubble aeration, which allows the media to be homogeneously mixed throughout the tank, which allows for better treatment. One other benefit that I think is a little less commonly known with fine bubble aeration as opposed to with coarse bubble aeration is you get less particulate breakdown. Now, what this really means is with a coarse bubble system, you have much more turbidity in your system. You have bigger bubbles. Those are going to have a lot more energy and they could break down the suspended solids that are in your water. So when those particulates move on to the secondary clarifier, they're smaller and they have worse settling characteristics. With fine bubble aeration, you have smaller bubbles. It's a little more gentle, a little bit more evenly distributed, so you don't have as much particulate breakdown. So when your water moves into your secondary clarifier, you're going to see better settling characteristics compared to an MBBR system with coarse bubble aeration. One more thing to note, again, when you use the fine bubble aeration, because you have a higher oxygen transfer efficiency, you're going to see even more overall efficiency in the system, so an even further reduction in the footprint. So the bottom line here is that pairing MBBR with fine bubble aeration is a match made in heaven. This is what we like to call our SSI E-evolved MBBR. That's because it's energy efficient, volumetrically optimized, you have low volatile effluent discharge, you have great settling characteristics, you have simple operations, and you have lower operational costs. we like to combine 3 different components to make our core MBBR package. That's the aeration system with PTFE, that's our MBBR media, and our effluent retention screens. Now, it's important for all 3 of these components to be designed together because they work together in your system. The effluent media retention screens are going to affect how the media and how the water moves throughout the tank. We also want to make sure it has proper scouring so there's not enough head loss, or there's not too much head loss between tanks. So we like to keep all of these together during design. So now that you know what we have been doing here at SSI and that we have a process team, why did we decide to make our own media? And the very simple solution to this is, or the very simple answer is, we wanted to control the quality at every single step. In the beginning of our process division, we were doing as many other engineering companies are doing all around the world, which is buying third-party media. And as you can see here in these pictures, the top left is SSI media, and the bottom is a very typical third-party media similar to a K5 geometry. And you can see easily here that there's a very big difference in the wall thickness. Unfortunately, we're not in person and we weren't able to set up video, but if we were, and I could show you that with just my 2 fingers, I can easily squeeze this third-party media, but I cannot squeeze the SSI media. There's a big difference in quality that we'll dive into in just a moment. But really what we saw was that when we were working with third-party extruders, perhaps where we get good samples, the samples look amazing, but by the time that your 15th or your 20th cubic meter of media shows up on site, you start to lose quality. And we were pretty disappointed in that. That can be due to the extruders not cleaning their machines frequently enough. It could be due to them not changing out their cutting knives frequently enough. When the cutting knife dulls over time, then you end up with warped media shapes. You also might see a difference in the wall thickness, and we just wanted to be able to control the quality to provide our customers with the absolute best solution that's going to provide the most longevity over the lifespan of your plant. We also wanted to optimize the geometry. So our process engineers spent a lot of time researching to make sure that we came up with the best design for your plant. So what makes our media different than all these other third-party extruders or other extruders all over the world? First and foremost, we only use a very high quality virgin HDPE material. There is absolutely no recycled material in our media. One of the biggest factors of the success of an MBBR plant is the strength of the media. And the reason why I say that is because if your media breaks, you're not going to have treatment in your plant. You're not going to have biofilm, you're going to lose treatment. And furthermore, if your media breaks, it's going to flow through your media retention screens and it's going to be discharging into your river or whatever discharge point you have. That can be a liability to your customer, that can be a liability to you. So we refuse to use recycled materials that cannot be controlled in our media. We have superior wall thickness compared to other medias. This again gives it additional strength. The strength is important not just so it doesn't break down over time, but so that it doesn't squeeze. If you can squeeze the media, you don't have a protected area for biofilm to grow. But wall thickness is not the only factor that gives our media strength. It's also a property of the HDPE material. We have greater elongation points, we have greater tensile strength. Overall, our media is going to be much stronger than competitors. In fact, you might find it funny, some of the ways in which we test this media. We like to put it through quite a rigor at home. We've done things where we've hit our media with golf clubs and hit other media with golf clubs and see which one breaks down first. But we also have much more scientific tensile testing, elongation testing to bring you the best media. We also optimize the geometry specifically to pair with fine bubble aeration. And we're also going to go into geometry design a little bit more after this. We have a specific gravity that is specific to fine bubble aeration. So specific gravity is really important because it's going to determine how your media floats or sinks or how buoyant it is within your water. So we have a specific gravity of 0.96. And that gives us perfect buoyancy in a fine bubble aeration system. With that buoyancy, that means that the media easily mixes throughout the tank. You get homogeneous treatment all throughout the tank. If your specific gravity is too low and your media is too light, it will float to the top of the tank. The issue with that is, in order to get it to homogeneously mix throughout the tank, you have to turn your aeration system up. We have seen situations with other medias where you have to turn your aeration system up 2 to 3 times more in order to get the media to mix. Now, like I said, operational costs for aeration is one of the biggest operational costs in the plant. So if you have 2 to 3 times more aeration, that's a very big deal to your customer. We also have shown in third-party tests that we have superior mixing and wet time compared to other medias. And we will be going into this in more details in our more technical presentations coming up as well. So MBBR is not plastic, it's engineered. And I think that's a good reminder for all of us. We know that it can be easy to look at MBBR and just think, oh, it's just pieces of plastic floating throughout a tank and biofilm just grows on it and any type of plastic will work. But we've seen a lot of MBBR facilities around the world that do not have adequate performance, and that's because they weren't engineered properly. So I want to briefly dive into some misconceptions about MBBR design. 2 of the most important design parameters are the SALR, which is surface area loading rate. That's how much of a constituent you can load into your tank based off of how much surface area of media you have in your tank. The other one is the protected surface area of your media. Now, theoretically, the protected surface area is supposed to be the area on which biology can grow, but that's not always the case. As you can see here, I'm not sure if you can see my mouse, but we have an image of a chip style media. This media has 3,000 to 4,000 square meters per cubic meter of surface area. That's incredibly high, but that's only physically does it have 3,000 to 4,000. Okay, once the biology starts to grow on it, you can see this biofilm layer here completely clogs all the pores. It's really like it's just growing on a penny. So in reality, your surface area that the biofilm is growing on is really going to be more like 200. And it's not even protected. It's all exposed on the outside of the media. Another example here is not a chip style media. It's more of a HDPE material, but the pore sizes aren't large enough. So you'll see that the biofilm has completely clogged these pores and there's no diffusion area for the water to move through the media. Treatment occurs where the water and the biofilm touch, right? That diffusion layer right there. So if you don't have water moving through your media, you don't have as much treatment happening. So what SSI has done is we have looked at numerous amounts of data, we have looked at numerous different geometries, and we have come up with a design that optimizes the protected area for biofilm as well as the open area for diffusion. So here, if you can see my mouse, is an image via a microscope of a biofilm carrier. And you can see that there's very healthy biofilm growth all along the protected surface area here, but there's also these really nice open areas for water to diffuse through. This will keep healthy treatment, this will keep efficient treatment. And this is what we have done with our media as well to ensure that we give you the best treatment possible for the media that you buy. So what exactly are our media options? Right now, we only supply one geometry, and that is a very optimized geometry that is great for 80% of treatment applications. We do provide this media in 2 different lengths because that does affect the open space within it. It also affects the protected surface area and the bulk density. So you can reach out to us for either of these options. These geometries we have specifically designed for fine bubble aeration. We have balanced the protected surface area with the open diffusion area. The surface area here is competitive with the K3 style geometries, which is one of the most commonly used geometries in the world. However, like I mentioned before, it has much better material properties than you'll see in most other medias. It has much better strength, you'll have a much longer lifespan, you'll have better mixing throughout the tank. We have designed this so that we can give you guys a great price and a great delivered value. So now that you know our process engineers have been hard at work to bring you the best products, what else can we do for you? Well, for large scale projects, we can also provide custom engineering solutions. Our design experts are experienced in a wide variety of industries. I understand that with standard sewage treatment plants, the water might be similar from one plant to the next, but every single wastewater is different. And so it's very important to consider all those differences and to provide a custom engineered solution, especially when it comes to industrial water, which can vary greatly from water to water. We'll be going into specifics about considerations with industrial waters, how they can vary, and specific case studies in our upcoming webinar. But the main point that I want to emphasize here is that there is no cookie cutter solution. There's no one size fits all with MBBR design. And so our process team is here to look at every single wastewater, its individual characteristics, and to provide it with a custom solution that's going to work in the long term and give you the best performance out of your plant. So what exactly can we do? Well, we can do the core MBBR design and delivery for large scale plants. This is what I was talking about earlier with our evolved MBBRs. This includes the MBBR media, the aeration, and the retention screens. Perhaps you only need MBBR, you're looking to retrofit, or you have the capability to do the primary treatment and the tertiary treatment. We can just focus on MBBR and provide that for you. We can also do full ETP design and delivery, anything from primary treatment all the way through tertiary treatment and water reuse. Like I said, our process team, we're not just experts in biological treatment and fixed film media, we're experts in a wide variety of equipment. We're constantly researching to find new procedures and new equipment to give you the best solution. We also have a package plant solution, which I'll dive into here in just a moment. Here is an example of a full ETP design and delivery. Now I want to emphasize here that every single plant is different, and I do not expect you to be able to read or to analyze this entire graphic here. The only point that I wanted to drive home here is that we can design every single part of the wastewater treatment plant. We can be involved from primary screening, neutralization, flocculation. Every plant is different. It'll have different needs. Some plants need grit removal, some plants don't. We'll look at your individual wastewater, decide what it needs, we'll design it, we'll deliver it. That is our full ETP solution. So if you're interested in that, if you have a large scale project, please feel free to reach out to us. We'd be more than happy to help. We also provide package plants. These are compact plants similar to our full ETP solutions, but just in a smaller package. It shows up on site already ready to be installed. On the left is one of the package plants that we have provided. On the right is a simple 3D graphic that shows that we have provided everything from the influent pumps, screening, equalization, neutralization, MBBR, rapid clarification, and effluent pumps. That's a pretty standard package plant design right there, but everyone may have slightly different needs. So we have 2 to 3 different solutions depending on what your needs will be. What else can we do for you? We can also provide technical presentations to your team and to your clients. I understand this can be very important for some of our EPC clients that we're working on custom engineered solutions for. Perhaps you are a representative or you are an EPC who is not a technical expert in MBBR. That's why you brought us on board to do the design. We can work directly with your client as your partner to do technical presentations, to explain to them what they will be getting, how to operate, things such as that. We're also available for technical support. We have multiple offices around the world, and we're able to be available for on-site support in a wide variety of regions. So looking to the future, what is next for MBBR specifically? Well, we've developed a new higher surface area MBBR media, and you're looking at it right here. It is not yet in production yet, but it will be coming in the next few months, so please keep an eye out in your email. When we do have it in production, we will be emailing everyone to let you know when it's available. As I mentioned before, we're always looking to innovate and improve, and this was the next step for us. The media that we have designed so far is a very optimal media to use in 80% of wastewater situations. However, we do understand that there are some situations in which a higher surface area media is more optimal. For example, perhaps you have a tank that has very low BOD, but you need nitrification. The biofilm in that case, you'll be growing more autotrophic bacteria instead of heterotrophic. So you'll have a much thinner biofilm, so a higher surface area media may be beneficial in that scenario. You may also have end clients who just prefer a higher surface area media. So that is why we brought you this product. And we're always looking forward to the next thing. So we may be bringing in more geometries in the future as well. Please look out for any new products we have and feel free to ask us any questions when they arise. That is our presentation for today. We wanted to keep it short and sweet for you, but we understand that you may have some questions. So please stick around for a Q&A session. Feel free to raise your hand or submit questions in the chat box. As I mentioned a few times, we will be having an upcoming webinar that dives into our MBBR design considerations and specific case studies. I think that for those of you who may be on this webinar who are much more technically inclined, or perhaps you are a consulting engineer, I think that you might find that webinar to be very interesting in terms of the technical knowledge and expertise behind it. Thank you very much, and I will start looking through some questions right now for answers. Okay, so we have a question here from Pete. He asked, how does the lamella type clarifier work for your MBBR applications? Is there growth on the plates that need to be cleaned on a regular basis? Do you use DAF units? If so, what is your preference? So a few questions all in one, and I appreciate that, Pete. We do prefer to use lamella or tube settlers with our MBBR applications. It's because the settling characteristics that the suspended solids have coming out of an MBBR are slightly different than the settling characteristics of a conventional system. So it's actually a very good pair with rapid clarification, the lamella or the tube settlers. We do not find that we have growth on the plates and that they need to be cleaned on a regular basis. If you do notice in any of your systems that you have growth on your lamella plates, there may be something else going on there that needs to be troubleshot, and we'd be more than happy to advise on that. We do use DAF units, however, typically when we use them, we're actually using them before the MBBR. So it's important to keep our fats, oils, and greases below 30 ppm on a regular basis. They can spike up to about 50, but 30 to 20 or less going into the MBBR will help to optimize the performance. So if we see a system that has high fats, oils, and greases, maybe such as a dairy, we always put a DAF before the MBBR to reduce the fats, oils, and greases before the MBBR. Fats, oils, and greases will affect any biological system, but especially in MBBR, they can bind to the actual biofilm carriers, and that prevents or that uses up some of the area that biofilm would grow on there, so you have less biofilm. It may also cause the carriers to float more, so you have more mixing energy. So that's why we like to keep the FOG low. We have a question from Danny Lee. It looks like it's pretty specific design, asking us for a bioreactor design based off of a COD. So Danny, we will, if you could email that to us, I think that's a bit of a longer discussion and very specific to that plant. So if you could email that to us, we'd be more than happy to get back to you on that. Here's another question. Is there a ballpark number on BOD loading to the MBBR system without primary treatment? So this is a very difficult question to answer because it depends on the wastewater type. So if we're looking at industrial applications, it's very important for us to understand what's coming into the water, and there may be a strict requirement for there to be primary treatment. If we're looking at standard domestic sewage, we always need to have screening before a biological system. So I understand that you may not have a primary clarifier, perhaps you don't have grit removal or a DAF, but we always need to have screening. We prefer with MBBR to have 2 millimeter screening. That'll make your system more efficient, but we can go up to 6 millimeter screening. For the ballpark number for the BOD loading, I assume that you're asking for the SALR, which is the surface area loading rate for the BOD. For a standard domestic sewage plant, we might see anything from 12 to 15, but it completely, again, depends on the individual wastewater. So the SLAR, first of all, is very dependent on the temperature of the water. The higher temperature it is, actually the higher you can load. But it's also dependent on how many solids are in the water, what's the FOG, how readily biodegradable is the water. But for a standard domestic plant, you may see somewhere between 12 to 15 for your SLAR. We have a question. Oh, I think it was answered. Sorry, it's a little difficult to read through here and answer at the same time. Okay, so we have another question here. It asks, is polyelectrolyte dosing required downstream the MBBR system prior to the tube settler? The quick answer to that is typically no. However, we do see a lot of cases where we will provide a dosing system for polyelectrolyte on site as a backup, just in case, let's say you have a wide variation in your flow or your load, or maybe in a year or two, you have different influent. You can dose polyelectrolyte if needed, but typically we don't need it with tube settlers. If you're going to use an MBBR with a traditional clarifier, however, we do highly recommend using a coagulant and flocculant. The reason for that is because, as I mentioned before, the settling characteristics of the suspended solids after an MBBR are different. If you try to imagine a conventional activated sludge system, you have a lot of suspended biology in your water. That's going to help you create bigger flocks a lot easier. In an MBBR system, we don't have those huge biological, suspended solids throughout our water because it's attached to the media instead. So the solids that are coming into the clarifier might be smaller, and therefore it takes them a lot longer to reach the bottom of the tank. So if you're going to use a traditional clarifier, we recommend a coagulant or a flocculant, but the better scenario would be to use either tube settlers or lamella settlers, and you'll get great reduction with that. Do we provide lab test analysis to help design MBBR for industrial wastewater? Unfortunately, we do not provide our own lab test analysis. We can tell you what tests need to be run, and you can send your samples to a local lab to get them tested and analyzed, and then send us the results, and we'll look through them for you. What is the lifespan of the media? Great question. When will media replacement be necessary? Absolutely, you should see at least 10 years for your media. Unfortunately, we've seen some other medias that have only lasted 2 or 3 years, which is absolutely insane compared to what it should be. High quality HDPE, the HDPE that we use has a proven lifespan of 15 years. So you should see at least 10 years out of your MBBR media, up to 20. What is the typical input quality for an MBBR system? That is also a very difficult question to answer because, like I said, every wastewater is very, very different. And the great part about an MBBR system is if it's custom engineered to the specific wastewater, every system can look very different. Some of the things that we typically look out for, though, is to make sure that like I said, your fats, oils, and greases aren't too high. That will interfere with your MBBR system. So make sure that those are on average below 30. You also want to make sure that your pH is in a proper range for healthy biological treatment. So we're looking at 7 to 8.5. You also want to make sure that you have enough nutrients, so if you're nutrient deficient, which can be common in industrial systems, make sure that you have some nutrient dosing prior to any biological system, not just MBBR. Other than that, I don't think that there's any typical input quality for MBBR. It, like I said, depends on the wastewater. So we can look at individual plants, and as I mentioned, it may be helpful for you to attend our upcoming webinar where we go over some different case studies and we talk about that specific wastewater and what we had to do with that. That might help answer your question. Okay, let's see. So we have a question here. Does MBBR technology have same performance as CAS or could be better, for example, with industrial wastewater treatment plants with high nitrogen influent concentration? That's a really great question. We will be diving more into that in our, like I said, our upcoming webinar. One thing that I will like to note here about MBBR that I briefly mentioned earlier is the ability to stage your bacteria into different tanks does give you better performance than a conventional activated sludge system. Because you are able to hone in on the specific type of bacteria needed to consume higher chain hydrocarbons, that means they can break down more difficult constituents. They might be able to break down more COD. They might be more adapt to nitrification because you can separate your bacteria into different tanks. So you have, you know, more heterotrophic bacteria in the first tank that's breaking down BOD. And then in your second tank where you need more nitrification, you have more autotrophic bacteria growing. That is a great benefit of MBBR because you can separate those bacteria. If we consider the same conditions, what can be the energy consumption between MBR, CAS, and MBBR? Really great question. So first I'll talk about CAS compared to MBBR. So in an MBBR system, you are likely going to see less energy consumption compared to CAS because you have a much smaller tank. So when we look at a CAS system, you might be looking at 15 to 24 hours of hydraulic retention time. That's pretty large, and you have to provide aeration for that entire tank. For an MBBR system, you might be looking at 6 hours of retention time or less for the same system. So you're looking at something that is half, maybe a third, sometimes even a quarter of what a CAS system would be. And even though our energy and our aeration per area is slightly higher, overall, because we have such a smaller system, we have less energy consumption in MBBR than we do with CAS. Compared to MBR, we also have much less energy consumption. That's because in MBR, you need aeration in order to have healthy biological treatment, but you also need energy on the pumps to be able to move the water through the membranes, and you need a lot more energy for backwash scours and such like that to make sure that the membranes don't get clogged. With MBBR, you don't have any of those, and so the energy consumption for MBBR is actually much lower. We have a lot of clients who come to us, they installed an MBR, and at first it was working great, but then after 1 or 2 years, they see their energy bill skyrocket, and then they come to us to switch to MBBR, which is significantly lower. Does SSI have references with MBBR and ultrafiltration treatments? So our process team here at SSI, as I mentioned before, is only 4 years old. So our reference list of installations with the SSI company name on them are not as great as our references of our actual staff. So the experience of our staff, as I said, Bob Freudenberg has over 30 years of experience. Jason Bowman has over 15 years of experience. We do have much more references from them. And those references are very valid because they're the ones who design the systems. We do have clients who use MBBR and UF systems together. We have not actually installed a UF system for one of our clients yet, although we do have some in the works at the moment. For package plants, do you need an equalization tank at all? That's a great question. Again, depends on your influent waters. So if you have a very steady inflow of water coming into your plant, you don't really have any peaks, maybe you don't need an equalization tank, or maybe you just need a very small influent channel or influent basin to help equalize flow. However, with a lot of our package plants, we find that they're on remote job sites, or they're on remote domestic sites or industrial sites. And in those cases, there can be very great variations in flow, maybe when the plant's on, like the industrial facilities on versus when it's off, or perhaps it's a tourist area and there's seasonal flows versus non-seasonal flows. We've even seen areas where the water was trucked in to our package plants, so you get 1 delivery or 2 deliveries every day, so there's a great variation of flow. In all of those cases, we do highly recommend to have an equalization tank. MBBR can handle greater fluctuations in flow than a CAS system can, but we still need to have that equalization tank to make sure we're constantly feeding enough water into our MBBR tanks to keep the biology healthy. Okay. Someone asked, please provide Excel sheets to design for diffusers. We actually, in our last webinar, we went over we have a online aeration design tool. So that will be much more robust and much more helpful for you. So please email us and we can provide you with access to our aeration design tool. Let's see. Do we need to consider a DO of 3 to 5 ppm while designing the aeration system? Typically for MBBR systems, we design for a DO of 3. Of course, your system can fluctuate a little bit. So let's say you want to put VFDs on your blowers. So you want to know what range of DO can be healthy for the biological system. I definitely would not recommend anything, well, for any biological system, don't go below 2 ppm of DO on your blowers. And then you could go up to 5 or 6. It's not going to have any negative impacts on your biological system, but it will impact your energy costs. So we design to a DO of 3. That's what we find to be optimal for the biological performance. But if you are at a very high altitude, let's say we have worked on some projects in Colombia where you're at 2,000 or 3,000 meters above sea level, then you will need to design for a slightly higher DO, perhaps 3.5 or 4, in order to have the best performance.
Yeah. Hey, Kelsey, this is Jason.
Hey, thanks for
tuning in. I was actually typing a response to that, so I just wanted to kind of chime in. First of all, thanks for doing this. You did a great job. A ton of great questions here. You guys can keep them coming. I love doing this type of thing. Also, feel free to email us personally as well. Email the team, and we'll take any questions offline, and we can answer them in more detail. But specific to the DO, we get this question a lot. And being an aeration design company and an aeration manufacturer for 25 years, one of the things that we see with the combination of our aeration systems and MBBR in general is that the oxygen transfer efficiency and even the mass transfer, the alpha value, in some cases can be increased compared to historic MBBR systems or conventional activated sludge systems. So saying that you require dissolved oxygen of 3 or 4 in an MBBR system, what a lot of people fail to realize is the oxygen transfer may be 20% better and the alpha factor may be 10 or 20% better. So just because you require a dissolved oxygen of 3 doesn't necessarily mean that you have to have more aeration for an MBBR system. In fact, in a lot of cases, we can show that the actual oxygen requirements or oxygen demand for an MBBR is actually lower than a conventional system in a lot of cases. So with that, Kelsey, I'll turn it back over to you. You're doing a great job.
No, thanks for that, Jason. I think it is good for both of us to be able to chime in here. I'm only looking at the question and answer box. I'm not looking at the chat box here. So Jason, if you notice any other questions you would like to discuss from the chat box, please speak up. Let's see. We have another question here. If your MBBR is divided into zones, will the aeration system, whoops, where'd it go? Will the aeration system be same or different? I would like one blower, or I mean, would one blower suffice with tapered aeration? So that's a really excellent question. Because we're going to see different treatment in the first tank versus the second tank, or the first zone versus the second zone, for large systems, we do like to have differing aeration systems from one to the other. But it may not be worth it to have differing aeration systems, because then you might have to have individual blowers for each of them. Typically what we end up doing is kind of what you're talking about here, where we have one blower or we still have common blowers, and we can kind of taper the aeration system from one tank to the next as needed. As Jason was just kind of mentioning a little bit before, your alpha factor may change from tank to tank, so that changes how much air you need to achieve the same DO levels. Also, because you're aerating the first tank, when the water flows to the second tank, you're already going to have a higher DO content, and so you need less air in the second tank to achieve the same DO. But those differences are not great enough for us to really differentiate them for really small systems. However, on large systems where you have very large energy consumption, it may be worth it for you to look at how to differentiate the airflow from one tank to the other. How does MBBR systems cope with anoxic tanks? Does the media work well with submersible mixers? This is another really great question. We have seen, and actually we've been involved with and installed MBBRs for anoxic tanks. I would caution that you need to be very careful with the type of submersible mixers that are selected. If they have too high of a tip speed, it doesn't matter how strong your MBBR media is, over time, it will break down that media. You'll end up with broken media. But that doesn't mean that it's not possible. You can supply mixers that have a low enough tip speed and still provide adequate mixing throughout the tank without breaking down the media. It's another reason in anoxic tanks why our media is actually superior and very important, because we have such greater strength than other medias on the market. So it's not going to break down as easily over time or in the anoxic tanks. What about MBBR in cold water? As with any biological system, temperature has a huge impact on how efficiently the bacteria can consume the constituents, right? So basically what you're directly impacting is the metabolism of the bacteria. And it doesn't matter whether you have an MBBR or a CAS or any other type of biological system, temperature is going to play a huge role. So we recommend that waters do not exceed 37 degrees Celsius. Once you hit 37 degrees Celsius, you're going to be hindering the metabolism of the bacteria, and you're going to be hindering your treatment. You're not necessarily going to be killing it yet until you get a few degrees higher, maybe 39 to 40 degrees Celsius, then you might actually start killing your bacteria. For cold, anytime you drop below around 10 degrees Celsius, you're not going to see much biological activity. So if you have I'm not sure what you mean by what about MBBR in cold water. If you have a very, very cold system, there might be a way for you to achieve biological treatment, but you might have to have a heat exchanger beforehand to heat the water up a little bit. Maybe you have another process on site that's domestic that can combine with it to bring in a little bit more heat so that we can have a good environment for our bacteria.
Yeah, Kelsey, let me jump in there. Hi, hey guys, this is Jason. We have applications in the Rocky Mountains that are operating, or we have experience with applications in the Rocky Mountains operating around 5 degrees, 6 degrees Celsius of liquid temperature. There are some careful considerations, as Kelsey mentioned. It is possible to remove BOD and even nitrify in those environments. However, the the kinetic efficiency is decreased quite a lot. But the short answer is yes, it is possible. and has been done. Once you hit about 4.5 or 5 degrees C, it's very difficult to get any nitrification after that or below that. Back to you, Kelsey.
I muted myself. I thought I was responding.
Yeah, I'm happy to start fielding questions if you need a break. Need to drink some
yeah,
water.
actually, that would be great. I might grab a glass of water and let you take some of these questions here.
Okay, cool.
Thanks.
Yeah, no problem. Okay, so let's keep going down the list here from Claudio. Let's see, typical question from our customer is, what is the sludge quality from MBBR system? So it will depend on if it's a domestic STP or an industrial plant. In general, what we find for like a BOD removal application would be somewhere between 0.3 kilograms and 0.6 kilograms of suspended solids per kilogram of BOD removed. A better way to characterize that is typically whatever the influent TSS is, the effluent TSS is probably going to be 200 to 300 parts per million higher. So if the inlet TSS is 200, we would expect the TSS from the MBBR system to be well below 500 in the effluent. Generally in the clarifier design and the clarifier waste sludge, the percent solids may range from 0.8 to 1.2% by weight. That has as much to do with the type of clarifier design as it does with the MBBR aeration design as well. So a lot of factors can go into that. Let's see, for the final sludge disposal, it's really site specific. We have clients that use, that basically waste directly to a sludge holding tank and can haul from there. Again, I would expect the average to be about 1%, 1.2% solids by weight. We do have applications where we use kind of a cursory dewatering device or a sludge thickener. We may get to 2 or 3%. And then we have applications where we go as far as using a screw press or filter press to achieve 15% or higher. So it's really site specific and client specific. Do you recommend MBBR for landfill leachate treatment? From Oscar. Oh, hello. Yes, we actually have quite a few applications, or I should say, the team has experience with landfill leachate. It has been used for both BOD, COD reduction and nitrification even. And in some plants we've seen, we've used it for denitrification even in anoxic setup. Landfill leachate can be a bit difficult just because the concentrations and the loadings are constantly changing. There tends to be pH issues and metal issues. So as long as we're aware of what the influent is, what may be present, metals, for example, we would make recommendations or supply equipment in addition to the MBBR system to kind of complement and so that they can work together. So let's see, I think that answers that. Roberto, good to hear from you. Let's see, any questions in the chat that we didn't come up with? All right, well, I think Kelsey did a great job with her introduction. As she mentioned, in the upcoming weeks, we will have a more detailed MBBR presentation that gets into the technical design. I know we get a lot of questions on a daily basis about how to design MBBR systems. So, as a process group, we're very proud and very engaged in what we do. I feel like we have a really good team, people with a lot of experience and a lot of different experience, even different plants, different industries. So, collectively, there's probably not many problems that we can't solve or have some type of, good positive recommendation for.
Yeah, that's good, Jason. And yeah, we're happy that all of you guys were able to be here with us today, and we look forward to, I guess, not really seeing you, but hearing from you on the next webinar coming in a few weeks. So if you could just keep your eye out in your email, we'll be sending out an email blast before that happens. and we'd be happy to go into some more technical questions at that time as well.
Kelsey,
Oh, we
see
have
yeah,
another question.
Trickling in if you want to take the lead, or I can do it.
Nope, you could. You're doing good. Go for it.
Yeah, Javier, thanks. Good question. Mixing in anoxic tanks. Historically, it's primarily been submersible mixers with a very specific propeller design and a very specific tip speed. So a lot of CFD analysis actually goes into anoxic tank design. The geometry of the tank and the depth of the tank can play an important factor. Historically, most engineers in the market would recommend something like 10 to 20 watts per cubic meter as a energy density or an energy factor. The more modern designs are more focused on thrust of the mixer. So if you can control the thrust and control the tip speed of the mixer propeller, in theory, you can use just about any mixer as long as the propeller is designed such that it is less of a cutting mechanism, if you will, more of a blunt edge, a leading blunt edge. And with the tip speed, basically we try to keep it to about 10 feet per second as a maximum. That just helps create kind of a barrier around the mixer. The higher tip speeds tend to pull the media into the mixer with more velocity and more energy. So we try to avoid that so we don't damage media long term. You'll notice with some of the MBBR carriers that Kelsey showed in her presentation, they're rather robust. And we did that on purpose because we have had anoxic applications, and we make sure that our media has a thick wall thickness, a uniform wall thickness, and I guess you would say, adequate specific gravity, so that the mixing, even with a mechanical device, a mechanical mixer, requires less energy even. So.
Yes, and to just go off that last point there, Jason, if a media has a low specific gravity, which we see in a lot of medias on the market, we might see specific gravities anywhere down to 0.92. We're up at 0.96. That media is going to float. So even in an anoxic tank, you're going to have a much more difficult time, homogeneously mixing that media throughout the tank. And I would actually say it's even more crucial in an anoxic tank, because you don't want to turn your mixers up too much. Like Jason said, you want to keep that tip speed low. So you need to keep a low mixing energy to be able to move the media. So if your media is floating and you have to turn up your mixers, you're getting too much energy and you might damage the media. So having that high specific gravity like we have with our media will do well for the anoxic applications as well. Okay, I see that there's no more open questions. Thank you to everyone for taking the time to join us today. We really appreciate it, and we hope to see you in a few weeks for our next presentation. And in the meantime, if you come up with any other questions or anything that you would like to see in our next presentation, please feel free to email us. You can email info@ssiaeration.com, or you can email Kelsey at ssiaeration or Jason at ssiaeration, and we'll make sure to get back to you. Thank you guys so much, and have a great day.
Very good. Thanks, everyone.